Okay, I think everyone is back. Hope you had a good lunch and a good talk. In this next session, Grappling with Data, I'm really proud to introduce you to James Baker, who's a lecturer in digital history at the University of Sussex in the UK. He's also founder of what you probably might know, the Library Carpentry. It runs as a series of workshops. And James is also a fellow at the Software Sustainability Institute. And I'll just give you a little story that it's a really positive story around communities, because I met James back at the Digital Humanities Oxford Summer School back in 2013. And I also met Thomas Padilla, who's going to do the second part of this Grappling with Data. So I think it's really gladly that being able to come here today and also to show us some of their work at this DST4L event. So give a warm welcome to James and have fun the next 4 hours. It's gonna be tough and rough, but also a good experience, I hope. So welcome, James.
Okay, so as Michael said, I'm from something called the Sussex Humanities Lab at the University of Sussex. We're a really interesting place. We bring together people who've got backgrounds in libraries, archives, humanities, information science, critical theory, music, information retrieval, this kind of stuff. And we kind of put these people together in one place and see what happens. And I've been there about a year, and we're very new. So do go and find us. I couldn't get the web page to load for obvious reasons. Do go and find us at sussex.ac.uk/SHL and see what we're about. We have lots of visitors from across the world, so if you want to come visit the UK and come visit us, get in touch. How many of you have ever used one of these flashy command line things? A good proportion of people. How many of you have used one in the last 6 months? The last month? The last week? Okay, anyone who said the last week, you pretty much become helpers for today, so thank you. Because the best way of learning this stuff is through peer support. So I've distributed some sticky notes that are gradually going around, and I'll explain them later, but they're also part of the peer support mechanism for the next hour and a half. And I've also distributed a handout, because I know library people like handouts, and something hopefully you'll be able to refer to. If you get lost at any point during this, the next hour and a half, if you go to data-lessons.github.io/library-shell, or go to librarycarpentry.github.io, you'll get to this lesson in some way or another. Obviously, it depends on your internet connection, and I have made some tweaks, so it's not just me repeating something I've done before. But that's somewhere you can go to if you feel like you're falling behind or need to refer back to something that I said. The purpose of this... Sorry? More handouts? Ooh. I didn't make enough handouts. Maybe you can share handouts. There you go. As part of peer support, you'll have to share handouts. Sorry. So if you have more than 2 on your table, give one up to someone else. And there'll be photocopies made. There you go. So the purpose of this session really is that by the end, you'll feel slightly more comfortable with that thing that's at the bottom there and what it's actually trying to achieve. I should say I'm not a programmer, I'm just a historian who ended up working in libraries and archives and stuff, who ended up with sort of problems I need to solve which required me to use computational methods, and I gravitated towards using that flashy command line thing for 2 reasons. One, because when I was a kid I used to have a BBC Micro and I loved playing with it, and then all of that curiosity was driven out of me by using Word and Excel and PowerPoint when I went to school. And secondly, because I went to a thing called Software Carpentry, which introduced me to a number of tools. I thought I was going to learn about how to use Python effectively, but instead I found that most of what I could do, or wanted to do at that time, could be achieved through this. I also found it a flexible place to do other stuff, to build other tools and resources and approaches on top of. So I guess I'm here because I like the control that this offers me. That control might not be for you. You may prefer using a graphical environment, such as Tableau, which will come up as part of this workshop. So it's very much, I guess, your decision at some point what sort of route you want to take. So see this as kind of introduction to doing things in a non-graphical way using that kind of command line interface. And hopefully I'll convince some of you along the way. I should say as well that this comes from a thing called library carpentry, which I won't say too much about, apart from to say that it's less kind of data science focused, perhaps, than a lot of what data science for librarians is about. We think a little bit more in terms of people's kind of daily practice who don't necessarily think of themselves as someone who wants to work in a data science frame. But hopefully, again, this should contribute to some of the things you'll be doing the next couple of days. So basically, what I want to do then in this session is introduce you to this thing by looking at how we can count, manipulate, and mine data in this thing called the Unix shell, which is a command line interface to your computer and to the files that it has access to. I won't go into too much detail, but a Unix shell is a kind of command line interpreter that provides the interface to a Linux-style operating system and Unix-like systems. So people with Macs, this is what you already have already. People with Windows, you have a slightly different command prompt by default, and that's why we asked you to install a slightly different one in advance. The motivations wanting to learn shell commands are many and various, but I would think you can quickly learn how to query lots of data for information that you want super fast. It's a simple place to kind of find stuff out about information that you have in machine-readable forms. And to give you an example, to give you a kind of sense of that, that's why this relatively complex-looking piece of code is there on the screen. And I'll come to that in a moment. Now, the first thing I might want to do is if I have a large spreadsheet, for example, I might just want to find out sort of some information about that spreadsheet. At this stage, don't follow all that I'm doing, but I'll tell you when the point we get to following along. So I might go to a place where I know I have a spreadsheet. I find that spreadsheet, and I might say, OK, well, I count all the lines that that spreadsheet contains. Live demos. Huh. It's a different one. Thank you. And straight away we find out that this spreadsheet has 5,375 lines. The beauty of this is in a way that it doesn't really matter which spreadsheet you're putting into it. It can be a huge one or a small one. It pumps out the response really quickly and tells you some information immediately about what you have. And what's going on there in essence is, and we'll come to this word count command, is that you're just getting a very simple sense of counting something within a file. Now, going back to our slightly more complex example, this is dealing with a similar file. And what it's doing is, in essence, it's looking within that file for some information, in that case about where it contains the phrase 2009. It's then looking for some more information, this international thing. It's then doing some stuff, and then it's producing some kind of result. We have more handouts. So I'm just going to adapt this slightly for one, slightly different than the one I made earlier. And all I did was paste that in, and it came back with a set of responses. And what the shell does is it always, by default, prints out into this environment as opposed to prints out somewhere else, or opposed to kind of gives you a separate file. And it's telling us these series of things as a result of the query we put in. Now, what I've tried to do there is I've tried to replicate the process where what I'm interested in is finding out all of the journal articles in a database of journal articles from the year 2009 that contain the word international in them. That's what I've tried to do. And then to count how many each journal has. That's all I've tried to do here. And I've replicated that through a simple query. So what we have here then at the beginning, where we got our bit where it starts grep 2009, is that we're asking the machine to say, look inside these files and find every instance 2009 in this particular file. We're then using this funny drop-down thing here to hold that in memory, to keep that for a minute, and then do something else. So after you've done that, then find international. Now, I'll put this in capitals because within this environment, it tends to care about things being capitalized or not. And I happen to know that in this data set, all the names of journals are capitalized. So it should pump out, without me having to worry about going to the right columns, it should pump out just those areas where there's a journal involved. And then doing this funny bit where I'm kind of saying, okay, well, go to a particular line, a particular column within this tab-separated spreadsheet, and just print out those variables that we find there. So in this case, it's actually the journal articles, the journal titles themselves, and then sorting it, and then doing this thing at the end, which is just saying, well, count the sort. So having sorted all these things into alphabetical order, if you see 5 BAR international series, just put that in one line and count that 4 times and give me an output. And that's all that's happening. What we'll see by the end of this is, with the exception of the slightly weird awk bit, most of the rest of that should become relatively clear what's happening. And you should be able to replicate that in your manipulation of data. Okay, so the first thing we need to do is begin with some real basics of the Unix shell. In order to do this is where the sticky notes come in. I should have kept 2 for myself. But what I need you to do is, if you're going to follow along from this point onwards, the yellow sticky note means I'm happy, and the pink sticky note means I'm sad. So on the top of your laptop screen, if you can just put your yellow sticky note up, to demonstrate, so other people can see it, so it points upwards, so turn it around and point it upwards, so everyone can see that you're happy. If you decide that you're unhappy with what's going on, put a pink sticky note on, and someone who's suggested they might be a helper, including some people over here maybe to run around and try and solve your problem, or me indeed. And what we'll do is we'll occasionally pause and then move forward, so I won't sort of move too quickly, is the hope at least. I'll also bring this thing further up so we can see it. Okay. So the first thing we want to often do when we're in this environment is actually know where we are, because it's not a very useful place. It doesn't have all the kind of visual cues we're used to for interfaces. And there's a command in here just called pwd. So within a comparable version of this, which should be a thing called git bash, which you downloaded in advance of the session, you should be able to open a screen that looks a bit like this, which I hope everyone has. If not, there'll be pink stickies going up. And type pwd and hit enter, and you find out where you are. And this is the crucial point where we find that some people haven't got anything open, or the thing that does the right thing.
You've done enough work already, I think, for that. Nice work. Yeah, usually there are more hands up.
I'm scared by the lack of hands. Or oh, there's a pink sticky over there. What's up?
When I type it in, that'll show me where
Okay, I have no idea what that is. Go back a second. Can you do ls? Yep. Yep. Oh, that's fine. It's because your default directory doesn't have a name. Don't worry, it's fine. Okay, I'm going to presume relative happiness. So, all this has done is printed out to the screen where we are. So in my case, it tells me I'm at users JB677 desktop data. You may be somewhere different. You may have nothing coming up seemingly because you don't have a base directory name for some weird reason, like one machine over there. So that's our orientation, the most basic step where we know where we are within a series of interfaces. The next thing we want to do is find out what's in that folder, in that place that we just printed out. And the command for that is one called ls, which is basically list. These things are supposed to be relatively human readable. pwd is print working directory, if you were wondering. And when you hit ls and hit enter, you should get something. Or you might get nothing because you've got nothing in the directory that you're in. But you get a list of stuff, hopefully. Now, the first concept I'm going to introduce, I should say all this is like the foundation-y stuff that then gets us to the bit that's interesting. The first concept I'm going to introduce is something called flags. Flags are things which, in essence, they modify these commands. So ls is a command, pwd is a command, and they change the behavior of that command. So if we do ls and a space, and hit that little dash thing, never know what it's called, and hit L, and hit enter, we get a slightly different output. This output is merely trying to tell us some more information about those files. So it's telling me the names of the files over here. It's telling me where they've got read-write privileges over there. It's telling me who made them. It's telling me the file sizes. It's telling me when they were last either created or accessed, not sure. Created, I think, in this case. My screen is kind of deliberately big, so you can't quite see it. You might see it better. So that's our first flag, in essence, this idea of changing a command. Now, one of the things about this flag that's interesting is that it's telling us the size of the files in bytes, and bytes is not particularly helpful because that's not very human readable. So we have other flags which kind of modify things further. So in this instance, you're more likely to use a flag such as ls-lh. And ls-lh has this h to it, which says, okay, make this human readable in some way. And so the big change comes in that we suddenly start seeing 29 megabytes, 1.8 meg, 1.4 meg, 13-bit, etc. We get this sense of the values that we ascribe to the size of data. So thus far, you've learned three things. You've learned a command that tells you where you are in this shell. You've learned a command which tells you what to find in that shell, what's in there. And you've learned that there's these things called... Oh, Thomas has broke a laptop. And you've learned about flags and how they work. Is that one settings?
Yes, standard settings.
I don't know why, but it's working like a Windows machine. So it's not working like, where is that here? There you go. You can make it bigger, by the way, if you click there. You can make the text bigger in the settings. So if you click on the top left there and go down to options, I know it's in English now, you can change the size of the text if you go that second one down. Yeah, go and select there. What's up?
I am getting help, but it's downloading.
Oh.
Yeah.
Oh, you got the wrong shell. You got the wrong command line.
I know, but it's the Git part is downloading down here. So.
Okay. This bit's the easy bit, so. You okay? Okay, we have mostly happy faces. If things start becoming really, really tricky, it may be easier to work with someone next to you, but we're mostly okay at the moment. Okay, so we've learned three things. We've learned two types of commands, and we've learned the concept of a flag which changes a command. Thus far, we've done nothing interesting. And the next bit isn't interesting either, which is we find a way of actually moving. So within your graphical user interface, you double-click on a folder and move. Within this interface, you can't do that. You have to tell it a command that helps you move. And that's using one called CD. CD helps you move to a folder, basically. And you have to actually have that folder already in existence. Now, if I go back to... If you just hit CD and enter, it takes you to the beginning all the time, basically, is what I've just done. Within this folder, I know I have a folder called desktop. And I know that because when I hit LS, it's one of the things that appears as one of my options. So desktop over there. What I really want you to do now is to move to any directory that you can see in the directory that you started in. And there should be one. If there's not, don't worry about it too much. Because all you do to move to a directory is type CD and press space, and then type the name of that directory, and then hit enter. And then it just moves us to a directory. So in this case, we end up in, once we hit PWD, we end up in users JB677-desktop, and we know we've moved. There's nothing that tells us we've moved, because it's just a command line, not a graphical interface, but we know we've moved there because we've checked it with another command. So CD desktop moves us there. You'll note this only takes you in one direction. So you type CD and you press space and you hit the name of a directory and it just moves you, keeps you going down that directory structure. This doesn't get you coming back. The way you come back is just by hitting CD, space, ... and then hitting enter. And that basically just brings you in the other direction. It brings you from whence you came. And I can prove that by using my PWD command to show you that. So I'm now in users JB677. I'm not in that desktop one. As I said, whenever you want to go back to the beginning, go back to the start, when you've got lost in your directory structure, you want to get back to the beginning where your computer sees its default directory, you just hit CD and hit enter, and it'll always take you back to that first place you enter every time you open up your shell. So just spend a couple of minutes making sure you're super comfortable moving between directories. So using CD, typing the name of a directory, and moving backwards and forwards. I won't spend too long on it, but it's just important that you can do that by default. Anyone who has a Linux or a Mac machine, you'll notice that this interface cares a lot about whether or not you're using capitals or not. I have to use desktop with a capital D. If you've got a Windows machine, it's unlikely you'll have to do that, just as a note. Okay? And as usual, if you don't know what you're doing, stick a pink thing up and I'll come have a look. Okay, I'm going to move on to the next set of simple things before we get to the fun stuff. So a couple of other commands that are useful to know. One is if you want to make a directory in this environment, you can't, again, just right-click, make a new directory, call it a name. You have a command for that, which is called mkdir, make directory. And then you could call that anything you wanted to, basically. Or you call it my first directory, or hello world, as people always advise people to do. But ultimately, the point is to say that that bit is important and that bit doesn't matter at all within this tutorial. Let's call it G. And then when we do an ls there, we find that there's a folder in there called G. Simple. And we'd navigate to that in the same way we just did before. Now I want you to find within your computer the folder where you downloaded some data in advance of the session. It was on the list of requirements. Hopefully you've managed to download it. If you haven't, then it's fine, I guess, until we get to a little bit further on. You'll maybe have to work with someone who has. But there should be some data you downloaded in advance. I asked you to put it in a folder called something like data. So in my case, it sits in CD desktop, and it's in a folder called data. And when I do ls, I see something like this. I see a bunch of files that have .tsv and .text prefixes. Now, what I want to do with that is to first show you how you can actually manipulate these files within this command line environment. Because we can do more than just say that things exist. We can actually do things with them. The first thing we can do is to take one of those texts and actually just print it out into this shell. So there's one there called 829-0.text, and it seems quite mysterious in terms of its title. So I'm going to type cat and hit a space and do 829-0.text. And then when I hit enter, it does something like that. Now, depending on your computer, it might just stream a whole information before you for a few seconds before it gets to the end. Now, I see that it says Project Gutenberg. So my suspicion is immediately aroused that this is some kind of book that's been downloaded from the Project Gutenberg website as a text file, which can be manipulated in this environment. We can find out a little bit more about this and what it's actually containing with a few other simple commands that let us look at the file. So if we type head, for example, and do 829-0.text and hit enter, we see the first 10 lines. It's harder to see on my machine because it's big. But again, we're starting to see this Project Gutenberg-y related stuff coming up. So head is a command there, and that should be in the list I handed out. Another one we can type is less. Sorry, not less. Is tail. And tail does the end rather than the beginning, basically. Here's what I want to sort of introduce a small sort of labor-saving trick that should work for most of you. Is if you have files in a directory that have names where, say, that's the only file that starts 8.2, then in most cases, in most shells, if you hit your tab button, it'll auto-complete the name of that file. Indeed, in this case, if I just type 8 and hit tab, it auto-completes it for me. So I don't have to keep typing in these file names. Again, the file name's wrong along the way, which is a very, very common error. And when I hit enter, again, I see some stuff. This is the end, the same as what we saw when we did cat, basically. We see the end of this file. So this is this Gutenberg thing, basically. Another way of manipulating a finer way is to do something called less, and then do the same thing. So less 829-0.text and hit enter. And this time it actually takes us inside the file. And every time we hit space, we start moving through it, and we start seeing that this is Gulliver's Travels by Jonathan Swift, a book which I'm rather fond of, which we can actually look at in this environment. I don't want to read it in this environment, but nevertheless, we can see what's inside a file by using this command, which can be useful to us. To get out of this, you just hit Q, and it should exit. That's Q. That doesn't come up on the screen. OK, so now we know a little bit about how we might look at a file. I don't expect you to remember all of that, but that's just some ways in which we can look at a file when it's in this interface. The final thing in terms of the basics is actually making copies and changing the names of these files. And this is where it starts becoming, I guess, slightly more useful. We have a command called mv, which means move. But it also kind of means rename. So if I do an mv and 829-0.text, anything I put after this becomes the new name of the file. So in this case, it would change it to a ridiculous thing without a dot something, which would be problematic. So I'm just going to call it Gulliver.text, because that makes sense. So all we're doing here is renaming the file to something else. It doesn't tell us it's done that. It's one of the things that people always hate about this environment. We need to then use our ls command to find out that it's actually done it, but I know it's done it. Trust me. When I do an ls, I see that I now have a gulliver.txt. I can also copy this thing. And I can use a command called cp, which kind of almost means copy. And I can say, well, let's have cp gulliver.txt. I hit just GU in that case and hit tab to autocomplete. And let's call another copy of it. Let's call it Gulliver. Let's call it Gulliver backup.txt. Let's create a backup copy in case we're working with this file and we want to make sure that it doesn't get changed in any way. And we hit enter, and once again, nothing happens apart from that it moves on to the next command line, but I know there's another file in there called Gulliver Backup. So we can now rename files, we can now copy files. We can also combine files, and this becomes really useful later. And it becomes very useful in particular when we think about spreadsheets and tabular data. To combine a file, we actually use this same command we saw before. We start with this cat thing, which we saw before, which was printing out to the screen the results of what it found inside the file. And if we do cat gulliver.txt and Gulliver backup.txt, if we hit enter now, which I won't, it would just print out both those files onto the screen in sequence. First the first one, second the second one. They're identical, but it prints them in sequence. If we use a funny little pointy bracket thing, that one, I don't know the technical name for it, what that is a redirect. And that says, take these inputs and put them into a new file. Take what I've done and put it into a new file. And we actually saw this earlier, right at the beginning. And at this point, I could just call it anything. But I won't. I'm going to call this one Gulliver twice. Because what this file becomes is a copy of Gulliver Travels made twice, basically. Once through, second time through, in one file, in one place. And when I hit enter, nothing happens, doesn't prove I've done it, etc. There is a way, however, that I can prove that I've done this. And that's if I use my ls-lh command. Because if you recall, that prints out information about the files that we have in that directory to the screen. And when I hit enter, you can see that Gulliver Backup is 592K, Gulliver is 592K, Gulliver twice is 1.2 megabytes, which is double 598K. The reason I put that there is because one of the things that often happens in the command line is you make a file, and somehow or other the process doesn't work. And you always know the process hasn't worked when this says 0. Or as close to 0 as you can. So this becomes a really crucial command every time you're working through troubleshooting what's going on. Once you build in more complex steps, one of the easy ways of checking if something's broken, you could be running a Python script in the command line, for example. An easy way of telling if it's broken is if it comes out with nothing. Something's not worked. And therefore you can go back and trace back through what's going on with the commands and work out what's wrong. Okay, so I've gone through a couple of things there. One is using MV, which is on the sheet, to rename files or to move files. One is using CP to copy files. Another is using cat to combine things and using this redirect thing to merge them into one final place. There's one little final thing I want to show you, two little final things I want to show you before we move on to the fun stuff. I'm just going to quickly make a directory here called backup. I can see that exists. And what I'm going to do is move my Gulliver backup to this folder. So I do mv Gulliver backup, and I do my little redirect thing. Actually, no, I just type that. And at this point, I do backup. Let me get this right. Backup dash Gulliver backup. all I've done there is move the file to another directory. So when I go to the backup one and have a look in there, I find that it exists. This becomes useful sometimes because the outputs of your commands, you want to put them somewhere other than the place in which the files you're working on are held. You want to put it somewhere else. And so sometimes you want to create files which move to other places. And this same syntax of going backup-Gulliver can be used after a redirect as well. This will come up again, but I just wanted to quickly show that move does something else than just rename. That it actually does move stuff. The very final thing I want to show you is this thing called RM. Anyone guess what RM might be? Removed, did someone say? Yeah. This is your equivalent of deleting. I always hesitate to mention this, but everyone always asks, so I have to. Remove does exactly what it says on the tin. So I'm in this backup folder, and if I want to delete my backup, I do remove Gulliver backup.txt and hit enter. The same syntax as copying, cat, etc. Always the same syntax. And when I hit it, it deletes it. It's not there. It deletes it forever. There is no recycle bin. There is no going back. That's the end of the world. And actually, it's very easy to delete things you really, really, really don't delete. So I always recommend not using RM, basically. I always find it one of the great ironies of IT security that often people don't have the access to like, install software, but they have the ability to install a command line that can basically remove their computer. So be careful using RM. But I needed to show you that one. Okay. Right, so what we've gone thus far, we've looked at some commands. So commands that help you move around this thing. These are the building blocks to actually doing anything interesting, whether it be using other commands in here which manipulate data or running software in these kind of environments. And is kind of, I think, incredibly useful then as a stepping stone to doing other things. So what I want to move on to is thinking about first counting information in files that we have. I'm going to go back to the beginning in terms of my directory, and I'm back in this place that my computer sees at the beginning. And I'm going to go back to this data directory with a load of data in it. Desktop data. As I said before, these relate to, because this is the same data used right at the beginning, these are files that relate to journal article publications. They're merely the examples I use because metadata about things, books, journal articles, whatever, tends to be a kind of common currency within librarianship. So most people have an understanding of the kind of things you're likely to find in there. In this case, they're split into TSV files. So they're tab-separated value files. They're plain text formats. They would open within Excel, but I think I can show you things in the next half an hour that you couldn't do in Excel, which you'd find useful if you're working with tabular data that's comparable to this, that has many lines and maybe sometimes need to be combined or searched across in particular, where you want to look at more than one file at the same time and find similar information. So the first thing we can do is use the WC command we saw earlier, this word count command. And if we do WC-W, it actually counts words. Word count doesn't work without a flag. It's a very strange one. And we can pick any file there. I'll pick the Africa file. And you'll note there that I started typing and tabbing, and every time I got to a stop, I added another letter or number so I could move on. Every time I'm tabbing, it's getting to that point where it says, well, you've got more than one file at this point with the same name up to this point, so you need to add more information so I can then move on to the next step. When we do word count with a flag of W, what we end up with is this output. And all it's telling us is the name of the file and how many words it contains. So in this case, 500,000 words, which is a relatively large amount of information. Not a huge amount, but relatively large amount of information. That's how many words it thinks it contains. I'm not going to go into how it defines exactly what a word is, but nevertheless, that's kind of the output that's coming out here. And like the other commands we saw before, you then change the flags to get different outputs. So were you, for example, to want to know not the number of words here, but the number of lines, then you do -L. and go through the same process and get a different output. So this is around 13,000 lines of data that we've got in this one spreadsheet. And we've got that information straight away. If we really wanted to, we could also know the character count. I don't care about the character count, but there's flags for that as well. And there's flags for different things we can do with the word count command. Now, thus far, all I've done is manipulate one file at a time. But I want to move on to manipulating more than one file at a time, because this is where it becomes, you start doing things you couldn't otherwise do easily, I think, with your graphical environments. So if we do WC, and we do -L, and we do, say, 2014, and let's go as far as that. We've got to a point where the machine has told us that there is more than one file, because I just kept pressing tab, there's more than one file that has a similar kind of structure to that. If I put a star there, can anyone guess what might happen at this point? I think I'm supposed to throw this at the person who says they want to speak, but anyway.
It will probably count the number of lines in both files.
Perfect. So this is what we end up with. We end up with a very simple count that tells us the lines of these two different files that have similar names. And I won't go into file naming conventions being a really useful way to manipulate data, but if you have reasonably and consistently named files, it makes this so much easier. And they have two different numbers of lines, 13,000 odd in one, 27,000 in the other, and we have a total as well. Print out the shell so we can very quickly know what's going on in these two files in terms of their length. We can then export these results. So whatever ends up on this screen here, if you remember the cat command, when we turned into a new file, whatever ends up in this screen, we can actually make into a data file of some kind. So in this case, we can take that same command we saw before and use that redirect to make a text file. So we have a report, basically, based on these two data files. And just to say, this wouldn't matter if it was 2 files, 1,000 files, 1,000,000 files. It'd take longer when it's 1,000,000, right? But it would still produce, still do the same thing, irrespective of the scale. And this is where this, I think, becomes increasingly valuable when you're working with large amounts of machine-readable information. Next little tip. You don't have to repeat this command, you don't have to type it out again. On your computer, if you press the up cursor, the previous thing appears. And if you keep pressing it, you go back through a whole list of things you've been doing. It's like a big memory bank of things you've been working on, which is incredibly useful. There's also this thing called history, which if you type history, it creates an output line by line of all the things you've done. I was working with something called Pandoc earlier, which I think will come up later. You've not got a big history, but there's a history file created. It doesn't go on forever. I can't remember how long it is. So you can occasionally export your history file if you want to keep all your different commands. And I have a folder somewhere of histories that I then search through for commands that I've forgotten about, because I forget everything. Anyway, go to this one. Now, I don't want to rerun that. I want to export this into a new file. So I just hit space, I hit redirect, and I hit results.txt, maybe? Could be anything. And when I hit enter at that point, again, nothing happens. We don't get an output. When we type ls, we can see that this results.txt is there. And when we do less results.txt, to quickly have a look at what's in it, we have our results in a file that's exported about these two different files. As I said, this could be 2, it could be many more. Something that we can very quickly work with that's separated by spaces, so we could probably open it if it was, we could probably open it as a tabular file within Excel if we wanted to, in order to print it out, present it, whatever. To get out this, again, you just hit Q. So thus far what we've done is we've used a command to look at more than one file and to create information about those files in another file. But this is thus far only information about the files. sometimes we want to actually sort of work with the information that's contained within the files. And that's where we come to actually not just counting stuff, but to actually mining stuff. So as you saw right at the beginning, there's this grep thing, which seemingly was doing something and looking for 2009, as I was saying, within this file. grep just means global regular expression print. Has anyone heard of regular expressions? Hooray! Regular expressions are a wonderful, simple programming syntax that enable you to look for patterns within things. So if you're looking for words which have slight deviations in spelling, for example, you can search for both in one at the same time. And there's loads of information online about regular expressions. They're super useful. They come up in loads of different programming languages and environments. So if you're interested in that kind of thing, matching kind of patterns, they can be very, very valuable. What this grep thing does then is, combined with that operator that redirects into a new file, is enable us to look within files and pull out information that we think is relevant and combine it in another place. So rather than sort of open up one file, go into it, sort it, say I want this stuff, copy, paste into there, open next file, do the same, open third file, do the same. We can look at multiple files at the same time for information that we're looking for and just pump it all into one place and combine it in one place. And this is where I often think that the spreadsheet stuff becomes the big use case, because for me at least, that's the thing that made me realize that this huge amount of information that I had in different spreadsheets that I could easily mine across and combine, to think of, to combine data in ways that otherwise would take me ages. It's kind of labor saving primarily, but also about combining information that you have. So, back in this initial directory, the data one, the one that contains these TSV files that you hopefully downloaded in advance. The easiest thing we can do is just search for something within all of the TSV files that are there, that are derived from this information, that is about journal articles. We have a question.
I didn't know we had to download anything. Are there any other than me that didn't download anything before? Okay, so I don't think we all have those data and are ready to do that.
Okay. So those who don't have the data, you have two options. Either find someone near you who does and work together, or go to Slack and look at the general feed there, in which there should be a link to all the data files. Obviously, that means we'll have to download them. If I have internet, I can show you where they are.
So we can pass around the files if it's Wi-Fi's.
We could pass around a USB stick. There's a USB stick going around as well. Okay. So on... Oh. So I uploaded a file, I think it was a couple of days ago, just in the middle there, called Grappling with data.zip. I don't know why it got data in it twice. It also is available via the Data Science for Libraries webpage, where there is a link from there to a place where you can download the data as well. Slightly different way on GitHub, which is a bit more difficult. So this is the easier way of doing it. If those of you who don't have the data, could you just put your pink stickies on, please, so I know? Thank you. And we can take 2 minutes while that's happening.
Was talking about how much he loves wget earlier, and in my particular use case, really just to get like bulk access to cultural heritage data from institutions that don't necessarily, have not. What's a nice way to say this? Have not. Yeah, I don't know. They had different user communities in mind. But there are some interesting steps in terms of trying to think in interesting ways about APIs that could make getting bulk access to cultural heritage data easier. Oftentimes, the APIs are focused on facilitating bulk access to the metadata, which is interesting, but it's not often the case that they give you bulk access to the actual objects themselves. Right. So, still area to be, or ground to be broken, or whatever, witticism, I guess. There are some institutions, I think James was mentioning. James, what was the one that's enabling, making it easier to use wget with? Europeana newspapers, I guess, makes it easier to use something like wget. At the University of Pennsylvania, they have a great project called OPEN, where you can use things like wget or rsync or anonymous FTP to bulk download the content. So for this particular use case, it's kind of like predicated on trying to understand the structure of a website, right? So it's often not the case that you can't just really just like use wget and say just like grab me all the stuff. You actually have to understand like how websites are structured in order to do that. I think some of the probably wasn't the intention, but James's section on sort of creating more of an orientation to how the computer is structured in terms of hierarchies of folders and things like that. It's not really dissimilar conceptually from how a basic website is organized. So, for this particular example, if we look at the, wait, that's not the browser, the Whitman archive, so Walt Whitman. And if you look at portraits of Whitman, I've often had the case, back in the States, particularly for history classes at the undergraduate level, that they like to use things like Omeka to create web-based exhibits of cultural heritage data, narratives around those exhibits, and they're often trying to find data, right? So when I see something like this, I'm like, oh, this is great. There are these images. There is like metadata for the images. I can view the images, but like, how do I get there's 128 images. Oh, and they're on 10 pages. But like, how do I get them? Like, how do I get the data? Like okay, I can look at it. And then I can click on that and it gives me a bigger one. But like, how do I actually get it onto my computer so I could do stuff with it? Right? That's where wget comes in. Okay? And part of the ability to use something like wget is you need to be able to instruct it to point at certain areas of a hierarchy of a website. Okay? So one of the things that I had done was I basically screen scraped the metadata from that page. Let's see if this opens. Okay. I was just saying so many nice things about Excel and it's not obeying. Okay. So if you look at these URLs, essentially, if you have these forward slashes, they're indicating directory structure, right? If you think about like the paths to different files and things that you're working through with James, it's kind of the same thing in a website. It's just like there's this website, and then there's a folder called multimedia, and then within that folder, there's something called image 019, and then this is all just kind of extraneous like display information, not really related to the organization of the data itself. So if we look at that a little bit more closely, and I've tried to use some color coding to make this kind of digestible. Yeah, okay, so if we click on that URL, right, so click on this, and it takes us here, right? So this is image 001. So this is the first image in this data set. But I want this like high quality one, this bigger one that is conveniently in a directory called large, right? Images large. It's a kindred spirit that I have out there. They have like a, same way of thinking. But essentially what you do is you just work through that. And so like through the scraping, I got basically all of these URLs. And then I basically just looked at that URL and then just copied the pattern and then iterated this number until it captured all of the content. Does that make sense? So just kind of like working with the structure of the data, and then I created a set of URLs once I understood the structure that would capture the higher quality images. So once you get the URLs, once you understand the structure of the website, once you create the URLs that you need, you then essentially have almost like an address book in a plain text file that resolves to all of the objects that you want. Okay? So in this particular case, I had created this this file here. It's a portrait.list text file. Let's see. Okay. Okay, so I'm going to go to the desktop, and I'll make a directory called Whitman. I'll move into the Whitman directory. And then if I remember correctly, let's see. James, did you tell them about the dragging the file into the... No? Okay. So I have a pretty basic command here. You got kind of an introduction to something like it with the foreign relations use case. But essentially it's just saying, hey, I want to use wget, wait 10 seconds between each time that I ask the server for this data, limit my download rate to 20K. Of course, you could also include no limitations. But then you might break stuff and it might feel bad. And then the I, which is just a flag, the I is just saying input a file for wget to reference. It's that address book that I was talking about. So if we include that, that might get messed up because of the, let's try. Okay, so it'll download that at a max of 20 kilobytes a second. You can see that. Now it's going to pause for 10 seconds. At least it should. And then it'll just go on and on and on. Right? So conceivably, this directory could hold like 5,000 images. Right? And you could just let this run for a really long time and get all that data. The world is your oyster. Right? And this is, basically exactly what I did in the foreign relations use case, right? In that case, it ended up being over 300 gigabytes of content. Who's used wget before? 1, 2, 3, okay, 4. Okay. I'm curious, do you guys have, I have the box. Would any of you like to share how you've used it? Yeah?
Well, I participated in, what is it, we call it, Hack for DK. And what I did was I, based on the dataset that DBC contributed with, which was library lending data, I collected all the authors who had a book lent out in 2014, and then I used wget to access Bibliotheksafgiften to see how much money they had received, and then I calculated how much money they received for every book they lent out.
Wow. Pretty cool. Thank you. Okay, so in the interest of time, I'm going to try and speed up a little bit. So FFmpeg It's a very powerful tool. It's often used by media archivists or AV archivists or media preservationists to do all kinds of crazy stuff. In this particular use case, it's more about like if you had a media file, a moving image file, and you just wanted to separate out different kinds of data from it. So if you wanted to separate out the audio track, if you wanted to stop at a certain level, if you wanted to reduce its size, if you wanted to create an animated GIF, this tutorial will show you how to do that, right? The last time I taught this, my students mainly just created jokes with it, lots of animated GIFs for the internet, and seem to enjoy it. So, FFmpeg, maybe I won't do, okay, and then SVID, and then move. Let's see. Okay. Okay. Okay, so this is the original video itself. It's the outgoing President Obama. Sad. You know, with his daughter and Michelle Obama at the in Selma. It's not a long clip. It's like 1 minute and 30 seconds. And essentially, the use case was like, okay, this is great. It's very high quality. How do I do different stuff with it, right? Like, how do I generate different data out of it? So there are some initial things that we can do with FFmpeg that are useful, like with the I flag. Basically, what this is going to do, it's going to generate a bunch of metadata that's stored in this particular file, right? So it's encoding the date that it was created, where it was uploaded to, its size, its extent, and different codecs that are used for handling it. So that's initially useful information as sort of like for like provenance and things like that. If you wanted to do something like, you know, create a segment out of this, you could do that with FFmpeg. So these particular flags, it's just saying, you know, start at the 60th second, the SS60, and with T to subset the data, you know, basically within a 20-second window, and then to input that file as the source file. Whoop. So if we hit that, it's going to be moving through every frame. Slowly subsetting. And then we should have a 20-second clip that starts at the 60th second. Okay. So I'm going to close that. The original video is pretty big, you know, particularly when your internet is fussy. This one's 128 megabytes. If you wanted to make it easier to share it DTU, you could do something like this. So this particular command, all it's doing is just saying change the scale of the film to 640 by 480, generate a new file. It's going to take a little bit. That's going to take a really long bit. Okay. So now, basically, we've gone down to a file that was 128 megabytes to like 18 megabytes. Okay. So kind of like simple, like pragmatic kind of stuff. I think during my workshop, I've said before that creating the GIF is like, hey, if you wanted to share something on the web in a cool way, you could create an animated GIF. I'll let you be the deciders for that. I don't know, how many of you have created animated GIFs before? I'm noticing the same hands going up. Yeah, it's like the same. Let's see. So if we have this here, wait. We have this here. We now have an animated GIF, right? So it's basically just a single image cycling through that you could put on the web somewhere. Okay. Now, in the interest of time, I'm going to skip the last two commands. Essentially, it's just how do you separate out an audio track from a video file, and then how do you edit that down. Right? So pretty straightforward stuff. Maybe more of like a public history orientation. Like if you're interested in doing like, documenting a particular community and putting it on the web. It's like a simple, but powerful local tool that you can use that's open source to edit video and generate it into new formats and things like that. Okay, we're on the last thing. We're almost there. Okay, and this one is actually really short. Let's see. So it's the FFmpeg plus ImageMagick. One of the great things about ImageMagick for the Windows users, once you get it installed, is that you invoke it or you activate the program by just typing magic. It's pretty good, right? Okay, so essentially I'm going to recreate part of the workflow for Scared to Death, the visualization of the Bela Lugosi thing. So if I go up again, and then I'm going to make a directory called Scared to Death. I'll go into that directory. And then I'll make two folders, one called Jumbo and one called Small. Okay, and let's see here. And then I'm going to move Scared to Death. Let's see, .mp4, move the file in there. Okay. Scared to Death. Okay, and this is the command that I used at the time. So it's basically just saying input a file, and then every 4 seconds, create a JPEG. And this particular component right here just creates the number of spaces to accommodate a growing file name. Sometimes that needs to be bigger or larger depending upon how many different files you're generating. Okay. Oh. Wait, but I want to be in the Jumbo folder. CD Jumbo. And I think I can do oh. Okay. So this is going to take a while because it's going to generate, I think it's like 1,200 images or 1,000 individual images out of the single video file. Okay, all done. So, Scared to Death. If we go into Jumbo, yeah, we have over 1,000 images. Okay. Now we use ImageMagick to make the montage. And that's a really simple command, right? So just saying montage, activate the montage capacity in ImageMagick. We put a wildcard or an asterisk in front of JPEG to say basically every file that has a JPEG extension. Combine all of those and make a new file called Jumbo Montage. Okay. Done. And then in Jumbo at the very bottom here, we've generated a montage, right? And you can zoom in or out for the entire movie. Okay. So there are an additional few commands in this particular section, but in the interest of time, I think because we're toward the end, I think I'll conclude the tutorial part there. I think we have until 5, so it's like 14 minutes. But at this point, I think I'll probably just circulate around. Use your pink flags if you have the energy and will, and I'll try and stop by. Okay? the stuff.
I bring it.
Yeah.
I'll play with it later.
Cool.
Are you working at UCSB?
Yeah, we're used to
I
it.
live in London.
Oh, cool. It's beautiful.
I live near.
Yeah, yeah,
Love that area.
yeah. Yeah, that's nice. Hi. I'll come around.
Yeah. I'm a little bit unsure if I install these yet.
Okay.
I see. I see that the directory
Yeah, so it's,
correctly.
yeah, so I think it's, I included a link in Slack, and that one will go to the executable, like the .exe. It goes directly to it as a download.
Okay.
And then you should be good.
I knew that from the beginning because left hand is open yet. So yeah. I try. Yeah. Now I'm out. Yeah, I go there on your on your link.
Okay, great.
Yeah. Great speech.
Oh, thank you. Thank you. Thank you.
Oh, there you go. Hello. Hi. I have some updates for you, but just to follow up on what James and Thomas were doing with their talks. So we're talking about what the researchers are doing. I think a lot of the examples we saw were in the digital humanities, like sort of exploration, the analysis that they're trying to do with text. One thing that I like to turn around and say, it's not only helpful, to understand what the researchers are doing, but we can turn that around and use it in our own work in libraries. And so here's an example of a project that takes advantage of some of the things that they talked about. So I used to work at the European Southern Observatory, and the European Southern Observatory, I think we talked about bibliometrics earlier. They were very concerned about tracking what was happening in the research, what was happening in scientific literature that used data from their facilities. Data citation, even in astronomy at the moment, is still not, like where we would want it to be. And so I would have to use the same mechanisms that they were talking about to sift through the literature. So I used this facility called the Astrophysics Data Systems, which pointed to links to papers. And I would extract the text from those PDFs and use keywords in the papers to basically find out if people had cited our data, if they'd mentioned that they were using European Southern Observatory data. Then we would find those mentions. So you see in this part right here, this is sort of a triage area where you can faintly see like some of the program IDs and other things that they're using in their papers. And so what we would do is link that back. So we would start assigning all those program IDs, and ultimately it built this nice bibliography of all the links that generated our bibliometrics. in a way, we were facilitating data linking. That goes back into the astrophysics data systems. And so now astronomers, when they're searching the literature, they don't even know that libraries have produced those data links for them, but they love it. You know, they'll talk about how seamless it is for them to go from a paper to a data set. But on the other end, it was ironic in the sense that our curation activities were driven by these bibliometrics, this need to understand how the facilities were doing in comparison to others. And just as a side note, I hope no ESO people are watching, but through this kind of analysis, we found out that Scandinavians were the most efficient, most productive in using the telescopes. So that never really went out there, but we could understand how the facilities were being used through this. It's just an example for you to understand. Maybe on the other end, you can also use this in your own work. And I very much like that, the fact that we're working almost similarly as our researchers. So it's easier, you know, we're doing it in our work, but it's easier for us to speak to them. And because of this, I actually, I don't have an astronomy background. But because I understood this stuff, I could have conversations with the astronomers about these various things. And just to give you another example, we worked with some researchers on a particular project. They wrote in a particular journal, and they wanted to understand data citation in that journal. And so in a similar way, and that journal happened to be with Elsevier. So we were lucky to get the full text files from Elsevier because they wanted to benefit from the data linking as well. So we mined the literature for links to data, and it informed a best practices paper that was widely read in the domain. So this is, you know, something you could do as you're thinking about your data services, is work with a particular group and understanding how this is. Getting access to this full text is a challenge. You know, open access is still sort of a dream that hasn't been fully realized. So one thing we were trying to look at before was that what I noticed in Pedro's talk is that PLOS is heavily used. There are a lot of people writing in PLOS here at DTU. So PLOS had a public data release, and that would be, you know, fantastic to look through that and understand how people are sort of, you know, what their best practices are at the moment in writing for PLOS, and if anything can be improved. So just some ideas for you in the library context and sort of the crossover between the groups. But updates. So we're actually going to be here for a while until the bus comes at 6:15. So you have some time to maybe also catch up on your work emails so tomorrow we're going to have GitHub training, Git training, and I highly recommend, since you saw what happened today, to download the GitHub desktop tool and follow the instructions that they provided to get ready for tomorrow. And also to put that into context too, like, it's been a struggle to understand how in libraries we might be able to employ GitHub. You know, the sort of underlying concepts of versioning and collaborative authoring. And here's some examples. You know, just one thing that I'm thinking about. Does everyone know libguides or libguides? Do you know that there's like 1,000 libguides on one subject? You know, like by subject librarians, they produce thousands of libguides that are almost the same. And so the tragic thing is, if you could use a tool like GitHub to sort of collaboratively build a guide together, you reduce all this redundancy that's happening. And you know, in some ways, I'm thinking about that for my own community. One of the questions on Twitter was, how do I take what I've learned here and use it in my own work. And so I'm looking at how in the libraries you can do that. So with my own group, trying to think about how they can use GitHub for their own guides or their tips and tricks or other things that they want to share with the researchers. And there is a project management tool in GitHub now, so maybe we'll explore that. But as you're looking at it tomorrow, you know, have that in mind. And I'll have something else to maybe say about that tomorrow. But did I miss anything else with the updates?
No updates, but I think we should give our two speakers today a big hand for being here. And also, I think you should give yourself a hand for staying into this.
Hello, everyone. A couple of things. Firstly, there are some delicious desserts at the back, which I'm told are festive specialities, which I've been enjoying. So I think that's your reward for the pain of the last hour and a half. Someone also spotted what I'm going to call a deliberate mistake in one of the exercises. I'm going to put it down to I work with collaborators on these materials, and someone changed something to be slightly wrong. So I need to figure that out and fix it. Later on in this session, after the break, Thomas is going to come back, after going through Open Refine, come back a little bit to command line processes. But I just want to finish by kind of saying that for me, a lot of these processes are quite mundane. They don't do super useful things. But the manipulating files is how I got into it, and it's how I still keep remembering all the basics of moving around the shell and sort of checking the sizes of files, all those kind of things, which I find really useful as part of other workflows. So I use the shell, I've been recently using the shell, for example, to run Python scripts in a cloud server, which is running OCR over image files of tabular data, which I'm finding in databases of tables of historical data, because that's something I'm trying to OCR. So the point is that you can use this same interface to do a whole bunch of other things. You can use this interface to run other scripts in other programming languages as a kind of foundation point for doing other things. It may not be for you. You may decide you want to do it entirely another way. But for me, it was a valuable way into thinking about computational processes and in taking control of how I work with the data that I manipulate as part of what I do every day. So I hope that's vaguely useful. There's a hand.
Now I'm going to throw it.
Hey.
Did you see that? I should get it. Well, I was just having a question because we're using a TSV file, but can you use it on Excel files and other files to do the same kind of thing, or does it have to be TSV?
Okay, that's a good question. So the environment will work with any file format that's machine readable. So it won't work by default with a docx or a Excel file, but it will work with TSVs, CSVs, which are in essence just tabular data anyway, because they're separated in this case by tabs rather than columns, and commas in the case of CSV files rather than columns in something like Excel. Equally, it works with text files. It's also very good at working with outputs, which you may be more familiar with, that come out of databases, for example, JSON files, which often come out of databases, or come out of you working with APIs, XML files as well. Anything that's in a plain format that isn't a screen-orientated format. Now, there are other processes here where there are other tools that do work with those. So Thomas will show you something that works with PDF files to strip the text out of a PDF. If it has that embedded text, you can cut and paste. There are some programs that run easily in the command line which work with music files, for example, MP3s. But here I'm just talking about things which work with, that look inside files for this kind of textual or data state information that to do with maybe numbers or words. And that tends to work primarily with these plain text formats, .text, .csv, .tsv, XML, JSON, etc. Okay. Coffee.